Okay, physical science. You are going to come in and remember you need to do the go to modules and you will complete the attendance. So go to today's date. This is in a chemical equation listed here. You have 2 sodiums plus chlorine gas gives you sodium chloride. The reactants will be on the left-hand side, so sodium and chlorine. Your products will be sodium chloride, the NaCl. Products are always on the right-hand side. The 2 means that you have 2, in this case, atoms, or over here, 2 compounds of that substance. If you have a subscript, it means that you have 2 individual atoms of that element that are bonded together. So 2 chlorine atoms bonded together gives you chlorine gas. Which 2, meaning the number 2, can you change in an equation, and it is the larger number 2. We call it the coefficient. It is the 2 in front of the sodium or the 2 in front of the sodium chloride. Those are the ones we're going to be looking at changing in today's lesson. You're going to remember, submit assignment, type in the text box, submit assignment again. You're going to come to modules. And before we get into today's lesson there, if you come down, you should have, and I don't think anybody did this yesterday, you should have completed the chemistry web quest where you would have seen some chemical reactions in action there, and you had to fill in a chart. Very simple. It's what you needed to do yesterday. Today, we're going to work on these 2 activities here. There'll be a video you'll watch, and then you'll do this activity right here. Before we go into that, I wanted to do some explaining. If you were in class, I would have you do this with a manipulative, with like beads or something, but we're going to go through this. Chemical formula for carbon dioxide. Remember, carbon is a C. Di means 2, so CO2. All right, how many atoms of carbon are in this compound? No number there. We know 1. How many atoms of oxygen? It has a subscript 2. If you change the 2 to a 1, is this still carbon dioxide? That means I would have C and O, and the answer is no. It is a new or different substance, and it's carbon monoxide. A coefficient is a number that you place in front of a compound to represent how many compounds it is. So if we put a 3 in front of CO2, you're going to use your distributive property, like in math. 3 times this 1 here means that you have 3 carbon atoms. 3 times this 2 means you have 6 oxygen atoms. Does the coefficient change the identity of the compound? No. But does it change? It changes the amount of compound you have. So this is something you've got to understand here. All right, now if we come here, what does the plus represent here? It means reacts with. What does the arrow mean? It means yields or produces. Do the small letters in parentheses, what do they represent? It's the state of matter that it's in. What does the AQ mean? Think of it as a liquid. It means dissolved in water. Alright, so in this chart, we're going to add up. R is for reactants, so it's on the left-hand side. I have 1 K, I have 1 I have 2 Cl's. I have on this side products 1 K, 1 Cl, and 2 I's. If I look, this is not balanced. Is there the same on each side? No, it is not balanced. No, it is not balanced. If I wanted to balance it, I'm going to jump ahead a little bit, but I want to go ahead and balance this. I would need to get 2 I's on this side. The only way to get 2 I's on this side is to multiply by 2. That 2 has to go somewhere up here, so it's going to go here in front of this because the I is attached. That means I also have to multiply the K by 2. Alright, so my I's may be balanced, but my K is not, nor is my Cl. So if I come down here and I multiply my Cl by 2 to get 2, so it's balanced on the other side, that means I'm also having to multiply this one by 2. So I have 2 of each and it is balanced. And I had to put these coefficients here in order to balance it. So we're going to look at a little manipulative here to see how this works. I normally would have you use beads, or in this directions it would say candies of different colors, but I tend to use beads. So magnesium, I'm going to use green. I'm going to use blue for oxygen. So I already have oxygen, so I'm going to put 2 together. They're stuck together because it's got a little 2 here, and there's 1 here that's going to be stuck to a magnesium, which is my green. So here's my magnesium, and I have a magnesium here. Alright, well I'm going to count. On this side I have 1 green circle, I have 2 blues, I have 1 green and 1 blue on this side. So I'm going to need to add to get to each side. So to get more oxygen, I need to add an oxygen here. Well, I can't just add an oxygen without it being attached to the magnesium. So I need to also add a magnesium. Alright, so now I've added 2. I have 2, so it's like multiplying by 2. So these are now 2's. Alright, my oxygen is good, but now if I look over here, I still have 1 magnesium. I have to have a second magnesium. And it's by itself, so I can just add a circle, so it's times 2. Alright, these little numbers here that I multiplied by, these 2's, I have to put as a coefficient. So I need to put 2 here because I have 2 of them. 1, 2. I have 1 set of oxygens here, so I just leave it alone. I have 1 magnesium with the oxygen, a second magnesium with the oxygen. Those matches my little 2's that I multiplied with down there. So I have a balanced equation. Alright, we're going to do another example. This time we have 3. I have chlorine. I'm going to do green, and I'm going to go ahead while I have green. I'm going to need 2 chlorines stuck together here. I need a chlorine here. I'm going to use blue for my hydrogen. I have a hydrogen here. I have a hydrogen stuck to this chlorine. I have 2 hydrogens stuck together here to make hydrogen gas. I am going to go to iron. We'll use red for iron. So I have an iron, have HCl, and then I have iron with 2 Cl's. So they're stuck together. So now I'm going to count. 1 iron on this side, 1 H, 1 Cl. I have 1 iron, 2 Cl's, and 2 H's. Alright, so in order to get a 2 chlorines over here, I have to add another green. Well, to get another green means I also have to add another blue because they are attached together. Alright, so now I have 2 hydrogens, I have 2 chlorines, and it is balanced. But this, I have 2 things here. I need to put a 2 here. All right, so that should be balanced. All right, another example, and this will be the last example. We have hydrogen again. All right, we're going to do carbon. We'll go ahead and put a carbon here, a carbon here. All right, and let's get oxygen, which I'm going to do red. All right, so I have 2 oxygens, and they're stuck together because that's a little subscript. I'm going to have 2 oxygens with this carbon, and I'm going to have an oxygen in this water, so I need to go get my hydrogens now, which are blue. All right, I have 2 hydrogens here. I have my Mickey Mouse ears, and I have 4 hydrogens here. And it doesn't matter where you draw them, but I just know they are generally spread around like that. All right, so I'm going to count. So carbons, I have 1. I have 4 hydrogens and 2 oxygens. Over here, I have 1 carbon, 2 oxygens here, and a 3rd one there, 3 oxygens, and I have 2 hydrogens. I'm going to start right here with my hydrogens. I'm going to try to get them to 4. So if I want them to be 4, I am going to add another water molecule here. So I'm going to need my hydrogens plus my oxygens. Alright, I have 1, 2, 3, 4. So now I have 4 oxygens. I have 1, 2, 3, 4, 4 carbons. Hydrogens. I need 4 oxygens over here. This is the only place oxygen is. So I'm going to just put me another molecule here. I have 4. So now I'm going to go back and I'm going to look. I have 1 of those, so I don't need to put a number here, but I have 2 of these, and I have 2 of these. It is balanced. For the law of conservation of mass, chemical equations must be balanced. The same number of atoms of each kind on both sides. That is why we add the coefficients. If we go back up here, you have this video, so you'll see some more of balancing there, but you're going to have an activity today and an activity tomorrow where you are practicing this balancing. So this one with the PhET activity, I'm able to embed this in here. So you've got your activity and you have your sheet right below it. And you'll already see that number 1 is already done for you because I did it in class already and my video didn't record my sound. You're going to type introduction here or click on it. You're going to come up here to tools. This is in the instructions, and choose balance. Alright, I would automatically go ahead and bump, whoops, let me go over here to make ammonia. Alright, I would bump each of these up to 1. Alright, so you can see a picture of their atoms here. See a picture of it here, and you see a balance up here. So when the worksheet loads, you will have a box where you will be putting the numbers in, and you will have a box where you will be putting drawing your little pictures in it. So you can sort of see mine loading. Things are being slow today. So while that's loading, I'm going to see if I can scroll back up here. Maybe not. Let me try again. Alright, we'll let it load. Alright, here we go. Alright, so automatically put 1 here. Well, notice I need at least 2 ends over here, so I'm going to add a second one here. Well, notice it balances my ends on both sides, so this is the end on this side, this is the end on this side. Well, Now my h's are out of balance. I have 6 here because 2 times 3 is 6. So to get 6 over here, that gives me 4, and that gives me 6. It's balanced. So what you're going to do before you move on is you're going to, and you can see my drawings even though it hasn't loaded yet, you're going to see that I have put in the numbers, and for me, using the board today, I used the writing tool and wrote it in, but you can use your text box to put the 3 in, or if you think you can write with your mouse, that is fine. I did 2 different colors here. I indicated the nitrogen gas in black and my hydrogen gas in green, so I drew a picture of what was in the white boxes, and I drew what was on the balance beam, except this grouping of 6 should have gone over here. So you will kind of see that that one's already done for you when you open this up. You will then click on separate water, and you'll do the same, and combust methane and do the same to fill in this chart. Then if you notice down here, there's the game. So right down here is a game. You will move on to the game once you've done those 3 balancing formulas. Notice it says to screenshot your score and paste below. When you get to the end of level 1, it will give you a little purple, I think it's purple window that tells you your score. You will screenshot that. You will come over here to media, and you will add media, and you will go to your Google Drive, and it should be there, and you're going to paste it. So there should be 3 pictures pasted here, level 1, 2, and 3. Each level gets a little bit harder, but you can keep trying. I want to just see your results at the end there. So that is the activity that you're going to do today. Tomorrow we're going to do another practice with online activity practicing, and then we're going to start doing it on paper, or on computer rather, balancing equations, and then we're going to move on to types of equations.